Hi class. So in my last video, I demonstrated how to model fraction division with a whole number divided by a fraction. And today we're going to learn how to show fraction division in our model, but we're going to have a fraction divided by a whole number. And we're going to talk about why the representation is bigger or smaller. Let's go ahead and get started. Okay, so let's consider the following. So let's say that I have 1/4 divided by 3, and I'm trying to model this. So if I'm going to model this, I think it's a good rule of thumb to go ahead and multiply it out. And I say multiply it out because we use the multiplicative inverse and we use the reciprocal. But we know that in plain person's talk, like KCF. So we keep, change, and flip. So instead of 1/4 divided by 1/3, we think of the problem as 1/4, that's the keep. We change our division symbol to multiplication, so 1/4 times, we check that off, and then we flip. So what we need to know about our whole number is that every whole number is always a fraction. It's understood that it's a fraction, and it's a fraction, or it's a whole number over 1 would be our original fraction, even if it's not written that way. So if I was finding the reciprocal or flipping the numerator and the denominator, then my reciprocal would be 1/3. And notice how I'm checking off each step as I go. That kind of keeps my head on straight. So I am going to multiply across like I normally do. 1 times 1 is 1, and 4 times 3 is 12. So I know that my model needs to demonstrate 1/12. Let's actually shade the model and see what we get. So in our previous slide, we got the answer 1/12. And the way that we got 1/12, we multiplied 1/4 times 1/3. So the way that we got that was 1/4 divided by 3. So now that we are trying to find a model that shades 1/12, we're really going to be shading just like we learned with multiplying fractions. So I already have my grid ready because I didn't want to make it very painful for you for me to draw that out with my with my pencil tool. So the way that I got my grid that I'm about to show you is by multiplying the denominators together, and I know that I'm going to have an area of 12. So I made a model that has an area of 12. And if you remember the steps from multiplying fractions and modeling that, you need to assign colors in order to shade. So I'm going to assign 1/4 purple, and I'm going to assign 1/3 green. All right, so whenever we shade 1/4, we are going to shade 1/4 of the whole shape, and I see that there's 4 columns, which means I need to shade one of them. It doesn't really matter which column you shade. I usually just shade the first one because that's what I usually do. Yours will probably be more beautiful than mine, hopefully. But you know, go easy on me. I'm using a computer system and I don't have a mouse. I'm trying to use my touch screen. So that's shaded pretty well. So I shaded 1/4 in purple, and now I'm going to shade 1/3 in green. It doesn't matter what row you shade, but it does matter what direction you shade. So I see that my shape has 3 rows, which means I'm going to shade one of them because I'm trying to show 1/3. And if I already shaded vertically, that means that I have to shade horizontally for my other factor. So, whoops, that's not perfect, but bear with me. Okay. So, not beautiful, but we're going to go with it. If you see the shape that's outlined with purple and green represents 1/12. You can see that because it's one of the small cubes out of a total of 12. So that is how you shade a fraction divided by a whole number, and you model it accordingly.